Okay, recording started, and you will find the recording after the call in the meeting notes as well, like from the last session. And let's jump directly into the agenda. Please always interrupt me if you have questions or additions or complaints or anything. So we are today on Friday, 11th of June. So this is the first official call. Last month we had the kickoff call, and let's do some organizational stuff first. So first of all, we don't want this to be an IBM-driven community. It should be a community-driven community. So the first question is there any volunteer for hosting or moderating the next session, so we can do some sort of a round robin? If yes, just speak out now or raise your hand or whatever you like. No volunteer? Okay. If you change your mind, just let me know. I will act as a backup, but yeah, I ask you, so I don't want to be a one-man show. No, okay, good. Then community updates. Someone wants to share something about something or about anything, and also speak up now.
Maybe I can just start, and then people still have a bit of time to think about it. So I guess from Embed to Scale side, we have two updates we quickly want to mention. I'm going to start with the first one about TerraTorch. I guess most of you know, but for those who don't, TerraTorch is our open source library for fine-tuning geospatial foundation models in a no-code, low-code manner. So to really enable everybody to interact and fine-tune those as easy as possible. And now we want to extend that to also handle embedding workflows better. So the idea is quite simple, just to split up the process, because right now it mostly treats the whole fine-tuning end-to-end. So you have a backbone and a decoder for your different tasks. And we want to split that up to also enable generating embeddings only with the backbone and saving them locally. And then later on being able to also train decoder task models on top of that. And given that TerraTorch integrates most of the geospatial foundation models, the goal is really to enable everybody to just try out all of the existing models already, play around with embeddings, and also within our community, enable everybody to treat those workflows as easily as possible. Also, thanks to some feedback, for example, from Clark University, that triggered this. And yeah, so I'm really excited also for the discussion later, because there's still some open design choices, like which metadata exactly to save, which format to save it in, before we release it then. So it will be great to hear a bit what your guys' requirements are for that.
Thank you. Isa, any comments or additions? Oh, okay, then I read Embed to Scale TerraTorch new core. Is that also something you want to talk about, Isa, or?
Not sure if Rickard is in the call.
Okay. I am. Was just not sure of the queue.
There's no queue.
No, so what we wanted to say here is not. I missed the last or possibly more of the previous meetings. I'm not sure what you've heard of the publication of the new code benchmark, but I guess that you understand a bit since Isa spoke of it. So that code is open source, but we're also, in addition to the extension of that to other data sets and other things, we're also slowly from Embed to Scale side starting to think of what else can we use it for. And one of those topics would be interpretability of embeddings. And this is nothing we have gotten or dug our teeth deep into yet, but something we are interested in doing, and also interested in seeing if someone else are working on it or have some ideas for it. So for example, topics that would be interesting to look into would, for example, be comparison between embeddings from different models, so interpreting the differences. And the other one would be, can we do some kind of feature interpretability methods for downstream tasks that works on the embeddings.
Cool. Thanks, Ricard. Comments, additions, questions? Okay, then we have something from Thomas Brunschwil, I guess. Is Thomas on the call? Don't think so.
He's not. So maybe we just pushed it to the end.
Okay. You have any idea what the topic is about?
I think it's best if he just shares. I think it's just about an event in a few months where it might be possible to host something for the community, maybe a small get-together if people are around. Yeah.
Okay, but it seems there's still time. Okay, good. Then let's push the focus topic at the end. Then we can have like an open discussion, I guess. Maybe better. Then we have here a feedback round. No, sorry, we don't have. We have here discussion opener. This is maybe not an update, huh? Should go here. Okay. Discussion opener, Jason. So Jason, you know what you want to talk about?
Yeah, okay. I'm gonna share my screen here so I can talk about a few things.
Cool.
Okay, so hi everybody. I am Jason Gilman. I'm the AI/ML applications lead from Element 84, and we are a geospatial company operating in the US, and we do work for people like NASA, NOAA, and commercial satellite providers. So we released a white paper on vector embeddings, and specifically about creating a vector embeddings catalog. And the paper itself is, I think, pretty good. It was kind of aimed at NASA, and in here we make the case for why should you create one of these? Like, what can you do with it? And this is one of the things where I think people know what vector embeddings are, at least in our industry. And there are some different groups doing things with vector embeddings, but as a whole, I think it's an underused technology, and there's a huge amount of opportunity for being able to just ask questions and understand things about the Earth. So I gave a talk at the ESA NASA workshop that was in May in Frascati, Italy. So I have a few slides here. And so by a vector embedding catalog, I'm talking about you take your Earth observation data, you chip it up, you generate vector embeddings and put this into a vector embeddings database and a system that's able to interrogate this, to be able to search across time and space and be able to ask questions about what has changed here, or can you find me, information, things where how much corn is being used across the world or things like that. And there's companies like Earth Index, they're a nonprofit organization, have been creating their own things like Earth Index, which allows you to find similar areas using similarity search. You can find things like rubber plants in southern Thailand or shrimp farms in the Gulf of Fonseca. And this is based on data that the user provides and labels. And there's real world examples like I'm thinking Radio Free Europe investigated a collapse of a quarry that killed, I think, 19 people. And they used Earth Index to go and try and find all of the quarries across the Balkans and then correlate those with licenses and then find out only half of those are permitted, right? So it's like a real world thing where it basically opens this up for all kinds of users. And there's so many different use cases here in terms of things like natural language searching, like being able to just access this, as a user, or doing change detection, being able to compare vector embeddings over time, or even doing that with natural language. And so there's a huge opportunity. And what I've been thinking about is what is this group needed for, and what can we do? And I think one of the major ones is establishing open standards, right? How do you represent this data for distribution in a standard way that can be used by other people? how do you, what does a API look like? If you build a vector embedding catalog, it would be great if there's a standard so that you could write software. You write like a build a cool UI, it can work with other people's data as soon as you switch it. Or we could be developing use cases and approaches, or at least showcasing those. I think evaluations is another big thing, like how well do the vector embeddings work for a particular model? And what about approaches, right? Cosine similarity, I've heard like might be a bit of a blunt tool, right? Not as good, but maybe multi-layer perceptrons that are trained on user data could be applied directly to the embeddings. And you could apply those in a really scalable way, across a whole bunch of vector embeddings and be able to answer things more accurately. As part of this idea, why not make an open source vector embedding catalog? If you're familiar with the spatiotemporal asset catalogs, and I'm guessing most of you are, like the idea with that open specification for earth science data, right, is they're not just creating a standard, they're creating an implementation too at the same time that proves out this is the way it works. And then I think also like getting these ideas out in the world. There are so many use cases here, both for scientific and also so much commercial opportunity too, right? There's agriculture, construction, finance, real estate, like all of these. And so that's it. But you can find our white paper if you go to our blog post, and then just links to GitHub where you can download it.
Thanks, Jason. Questions, comments?
I would have a question, Jason. I was just wondering, did you guys, when you wrote that and thought about it, ever also think about multiple modalities, like how you could include that into a vector DB?
Do you mean like SAR versus optical versus like other things?
Yeah, for example, because then you would have different representations of the same location by like different sensors or also different bands that are being collected, and how that could be like effectively translated into the data store.
Yeah, absolutely. So it would be interesting to think about it like, do you create vector embeddings separately for all your SAR data and separately for your optical, or do you use a model that can take both of them in and create a single vector embedding, which seems like probably the best approach if you have a model that can do that. I don't think we wrote about that in the paper though.
Yeah, no, I agree with you that this is probably like super informative, but then you might also want to keep some of the granularity if you do it early in the data pipeline for later use. But yeah, thanks a lot.
Alex, you still want to talk, or do you raise your hand?
Yeah, just like if the discussion continues on the point, Jason and Isabel, I'm curious about the interpretability of embeddings downstream. So I think Google about like 2 weeks ago published their satellite embedding V1 dataset, right? And they implemented climate data, optical, SAR, a bunch, and just combined it into these annual representations of embeddings, which in a way opens up interpretability between the sensors. But then my question is, how do you relate what variables in this vector embedding downstream? So you have like an annual representation of a geographic location. How do you sort of run an analysis to say what in the embedding is actually, like, what does this output actually tell me? Like, from what source? How can you trace that back then? If you have just one vector embedding that represents multiple sensors at a time.
Yeah, I think that's a great question. And I don't know, maybe other people might have ideas there, but I think that could be like, what part of our group is like the identifying what are problems, right? And how do you solve them? And I think one of the things I was thinking about is you go through and label vector embeddings like ahead of time that represent different kinds of things, and then use that. But I don't know if that gets completely to your point.
Yeah, I mean, I think like the way I was trying to bring explainability into the problem was then mapping different variables downstream. So like in a specific location, the output of the vector embeddings, then I would map that to like a Sentinel image and ECMWF forecasting data, stuff like this, to understand sort of like the local data that's behind these embeddings. But still, I'm having trouble in sort of actually know what's driving the definition of a vector representation of that area, given that it has like so many modalities involved. And I'm not sure how to compare this, as you said, Isabel, like if it's better to create these data sets separately and then in a common latent space, I don't know, if a way to like combine these different embedding data sets and know what you're pulling from each to say, okay, I'm adding the ECMWF forecasting embedding data set plus the Sentinel-2, and I know that I get this output, rather than just like cramming everything in and I guess having something interesting but not really knowing what driving. Yeah, I don't know if I see some hands up, so I would love to hear your thoughts, guys, or what you've been doing with this.
I have to restart my Teams. It's gone completely white. Be right back.
Hey, so I'm also from LMN84 and one of the co-authors of the white paper. I don't know if he addressed this specifically in the paper, but I gave a presentation at FOSS4GNA last year where I talked about exactly this. Like if we standardize the grid we're using to create embeddings, then we could potentially have like multiple catalogs, each from different sensors. And then when you're applying it to a downstream task, you have the choice of picking and choosing which sensors embeddings you want to put into your downstream model. And like there's a bit of a trade-off there, right? Like the more embeddings you choose to put into your model, the larger your model has to be. And so like in some cases, it might make sense to have embeddings that are like synthesized from different sensors into just one embedding. And in other cases, for interpretability, like you were saying, it would make sense to have those embeddings separate. But yeah, as long as we have a standardized grid, then we can even have like embeddings from different models for the same modality. Like maybe like one model excels at capturing a certain kind of feature, and other model using the same modality excels at something else. And if we combine those embeddings, we might have something better.
Okay, thanks. Then Amit.
Yeah, so sorry, my camera is off. I ended up being on the road. But I mean, Adil kind of mentioned the comments I wanted to say. But one thing I would like to add as like a comparison to existing pipelines is think about land cover. I mean, as of now, for example, we have 3 global land cover products. One is like the ESA word cover one is the Google Dynamic Word one, the other one is the Esri Impact Observatory one. All of these are derived from Sentinel-2 with different models and a different approach. 2 of them are annual land cover maps based on the time series data. One of them, the Google one, is the scene-based one. But all of them claim to do land cover mapping at global level with a certain taxonomy, and 2 of them are very similar actually in taxonomy. But as a user, you go and say, oh, I want to compare these products, which one does better on this application or in this region versus the other one. And you have a catalog that you can easily query and basically compare them. Where we stand with embeddings now is we are gradually generating more of these using different models and different modalities and different sensors. But there is not an easy way. I want to basically highlight what Jason mentioned. We don't have an easy way of querying and accessing the embeddings. It's basically zip folders somewhere on a GitHub repo or on a website that we have to download. So that kind of underlines the importance of having an API and a catalog. Romeo, is this a good place I share the update and that proposal as well, or you want me to wait until later? Yeah, so related to that, I briefly touched on this in the last kickoff call, but there was a funding opportunity from the Navigation Fund to basically support convenings of technological things that the community needs to get together, do some hackathon sprint type of work to advance some specifications, some community standard. So with the lead of Radiant Earth, the organization who actually spearheaded all of the stack sprints and development, we submitted a proposal to get funding specifically for these embedding standards and cataloging practices, basically. The funding is just for 2 sprints, and hopefully if it comes through, we'll have travel support for like 20 people or so to come together and basically have a couple of days of in-person deep dive on how should we do this, what are the specs, and do this iteratively, because the way Stack was developed wasn't an overnight specification. It took like 2 years of back and forth iterations and implementations to come to a standard 1.0 release, basically. So that's the hope, that's the effort we put into, and as soon as we hear back, I will share with the community. And I reached out to some of you when we were submitting the proposal to get a quick initial feedback on it. It was a 2-page thing. So fingers crossed, I will share that update as soon as it comes in. But we hope that we'll have some convening opportunity later this year and early 2026. Yeah.
Awesome. Thank you, Hamid. Then we have Sumia.
Hey, sorry, I have my video off as well. I'm also in the middle of a road. I'm Samya. I work as a machine learning engineer at Development Team. So because we are discussing Stack and embedding, last year we did some experiment around Clay. So we're trying to generate embeddings from Clay and store it inside Stack Catalog, and then have an ability to query it. We didn't go too far. It was more an experiment that we are doing during pod week, but I can share like some of the initial learnings that we had during those experiments with the group.
Thank you. Oh, and now I remember, we talked to each other via a GitHub issue when I was integrating Clay 1.5 into TerraTorch. we had a discussion. Now I know where I know your name from. Thank you. Then we have Mitran.
Hi, yeah, so I'm really new to this embedding space thingy. So I just wonder, like, what exactly are the reasons that we cannot use the technique from interpreting the CNN and like all the computer vision model with their interpretability like ML thing? What exactly cannot be transferred here?
Okay. Anyone wants to take this one? Any volunteers?
Yeah, isn't it not when we have usually models and we have multimodal inputs, then the explainability methods could indicate which modality was more decisive for the conclusion. But if you have now the embedding, which is already coming as one multidimensional vector, and we don't know what the dimensions mean, then I guess isn't that then the problem that we don't know which modality influenced now mainly the decision? Is that kind of the explainability you were asking, Alex? Or so in excess, I would see kind of if you have multimodal input from features, then we can see kind of what is more relevant and what not for the decision. But like if it's a feature vector, then okay, maybe we see is that, yeah, I think that's kind of probably the tough part, because we don't have an interpretation about these dimensions as of now, unless Romeo hacks the unified embedding space and gives it meaning.
Yeah, maybe I can also do a quick update on that one. But then the other thing is, I don't think it's not possible, no? So you could use ordinary methods which take the model as a black box and apply the ordinary interpretability algorithms on top of that. I think, especially when we have information where the embedding came from, and then we have a certain downstream task. I think after that, we have that model and the original input data, we can apply the state-of-the-art interpretability methods and algorithms on top of that.
Yeah, exactly. But so maybe asking like what kind of explanation would you aim for? Is it like which modality was more decisive, or what would be exactly? So just like wrapping the head around what is explainability meaning in this context exactly.
I
You have
think
an opinion on that, Soumya? No?
Yeah,
please go ahead, Adi.
I think it's not just the modality, but also like what part of the image influenced the decision at the end, like the pixel in the pixel space. So, and yeah, that's the issue with embeddings, because you can't trace it all you can't trace the output all the way back to the input image, because that's now gone, and you just have the embedding, and you don't have the full model to like back propagate through like some of those interpretability methods do.
Okay, then we have Vitran again. No, sorry, Matej. Hey, Matej.
Hey, yeah, I just wanted to add here that maybe in CNNs, the deepest levels of the CNNs still carry on some spatial information reduced to the lowest level that you have in your UN model, for instance. So it is kind of simple to look at the lowest levels and the weights there and see that there is some spatial correlation where the important bits are coming from. And when you go to embeddings, this one-dimensional vector does not carry these as clearly represented as we are used to maybe from CNNs. So it's really in the latent space of the embeddings. And while probably some, as Romeo mentioned, some typical analysis tools can get you to the point where you're analyzing the principal components, but it's very difficult. It's significantly more difficult to disentangle that back into where in the input image that is coming from, where in the, not only the spatial, but where in the spectral part of the information this is coming from, and so on. So I think it's much more difficult to disentangle information from the embeddings than we are used to, and we are probably lacking tools as well.
Good, thanks, Mitran.
Yeah, I want to add on that, like, I read the architecture of the TerraMind model, and from my understanding, they keep both the embedding space and the pixel space. So I just wonder, if all the models only have the embedding space, but what if we learn from the TerraMind architecture and keep also the pixel space, then we can use embedding, but then we can do something interpretability in the pixel space as well.
Yeah, probably. Any experts on that question? Who knows the shape of the TerraMind embedding best? Isa, probably.
Yeah, maybe I can add a little bit to that. I guess most of the more recent foundation models are based on vision transformers. So most of them produce one embedding per input patch. I don't know, 8 by 8 pixels up to 16 by 16 pixels. But then I feel like right now in the embedding space, a lot looks at image-wide embeddings. So averaging the embedding across all of the patches and then getting one image-wide embedding. And then you definitely lose kind of the patch information and kind of aggregate it to one image embedding. In favor of doing getting a smaller embedding, doing find better, doing image-wide applications. So that's definitely trade-off here, how big should the embedding be, for how much spatial information do we still need? Yeah, to comment on that.
Thanks, Isa. Okay, any other comments? Anybody? Then there's Alex.
Yeah, thank you. I think just going back to some points of Matesh made, I wonder if maybe part of the underlying problem of this spatial representation, lack of spatial representation in the embedding space, has to do where we borrowed the original architecture of vision transformers. I feel that the current embedding, or most of the field of embedding space creation, is done over the pixel an image as a visual representation and recreation of the data. But from an Earth observation background, I feel there's I'm not sure I can find the words for it, but more truth representation of what that pixel actually is. Not just what visually the model is understanding, but actually the spectral information. And I'm not sure if at a certain point we'll want to consider architectures that are working at this other level of data representations at a pixel level. I don't know if that makes sense.
Thomas?
I was just wondering, exactly because you're bringing this up, isn't Google's embedding exactly pixel level? Maybe also incorporating kind of surrounding pixels to inform it. But okay, nobody of us has seen the paper, right? Okay, so maybe it's now all speculation. But my understanding was like at least there we would have a pixel level embedding.
Okay.
Yeah, but let's
Yeah.
see. Maybe when the
Yeah.
paper comes out, we can do a summary. Discuss it here again.
Yeah, we meet anyway in 1 month now, so we can see.
Because I think the in LPS, I think after your talk, Thomas, I forgot his name from EPFL, that they presented like a smaller model where they were working in the spectral space, right, for modality comparison. I don't know if that's like a direction of like finding a common ground for explainability for embedding spaces, like finding a more common ground amongst sort of sensors that they can like then communicate at another like data representation that is easier to interpret, rather than having the second interpretation of a model that looks at an image and then learns whatever it finds interesting between groups of images. Like I feel like we're working currently at a third or fourth level interpretation from an image sensor that's converted, then a model that interprets and learns that, which then gives us a vector embedding that represents that, and we're trying to untangle that. I'm not sure if there's things we can cut in this pipeline to get to a second level of explainability or so. But yeah, I think I guess we'll wait for the Google paper and go from there.
So do you mean the paper by Genther, Smarties, or what was the name? Something like that? Can it be?
Yeah, it's Smarties. Exactly. I was referring to Smarties.
Yeah.
Alex, maybe one more thought to add to that. I'm totally with you, and I think really, really important topic. But I think it can also be a bit reverse engineered by understanding the latent space better. I think when we start exploring embeddings and like learning about correlations and how similar certain embeddings are, this will also help us to address those issues better and then see what they actually capture and try to understand it from that angle as well.
Good. Then let's have a look at the agenda. So the status we already heard from Amit. Then, yeah, in which way are we already working with embeddings, format, storage, what sessions and requirements do people face? Not sure who wrote that, but let's have a go on that one. Shall I just start? I have a 2-sentence update. So we are currently trying to work on a unified embedding space. So the idea is we train on multiple embeddings from different foundation models using a GAN, and then have input adapters into the unified embedding space and output adapters. And we basically train the input and output adapters for all the foundation models. And we are hoping to find a joint embedding space. And that if that really works, it would be awesome. Then we could somehow standardize on that UGS and could learn from there and have third-party or new foundation models also to adapt into that unified embedding space. So that was my update. So any other updates from anybody? Bye, Rocco. Take care. Nobody?
So Romeo, is it general updates or technical? I would just have one comment. There is the Big Data from Space conference in October, so maybe that could be a good place if some of us are there to meet. I can post you the link.
Yeah, maybe you post in the Teams chat, and I put a link in the notes.
Yeah, it's here in the Teams. So it's on the 1st to the 3rd of October. It's the Big Data Forum from Space from ESA and SATSEN in Latvia. And so they also have a Birds of Feather session, so where we could again have a a bit of a guerrilla Earth2Vec event if people are there. So let us know if somebody joins there. I don't know, Mate, you going there? Like,
I'm not yet sure.
yeah. Okay.
Yeah, if you would want me there, I can push for it. Yes.
No, but exactly. So I think it could be an opportunity kind of to meet here in person.
Yeah.
People go from
I know.
Earth2Vec. But yeah, I think we meet
Okay.
probably.
Good. Okay. Then any other updates? I don't know who put this agenda item in, but yeah, challenges, requirements about formats and storage. We'll talk anyway at the end if we have still time. Okay. Otherwise, then next topic is feedback round. Do we change something in this community? Can we do something better? I know we had some issues with Slack, but probably it's too late to now move everybody to another channel. So let's live with that. And if you have problems joining the Slack, just ping me via email and we will find a solution. There is a workaround. Maybe I tell you the workaround now. The problem is if you register with an email. Oh, Mattia, I saw your hand raised. 1 second. So if there's a okay,
I'm
yeah,
sorry.
go ahead, yeah.
I have a question for the public here. Is there any other typically used metrics on the embeddings when dealing with search, apart from cosine similarity, that you would propose looking into?
I mean, Chakard distance, I hear sometimes. Don't know if that makes sense in this case.
Yeah, I mean, Euclidean distance as well, but that is a bit tricky when you're in so high dimensional space anyways, and cosine.
Yeah, Manhattan distance, I don't know.
Oh, you're just going to worse. So if somebody has additional ideas, please reach out even on the Slack or anywhere. I'd appreciate it.
Okay, I saw from Jason a link. At least you have a list now.
Yeah,
you can walk through that. And let us know if you have any findings.
So there is an approach that I heard Earth Genome has used where they, instead of using cosine similarity, I guess for the things where they really care about finding all of the matches, they train a small model using like input data and then use the model basically on the vector embeddings to say, is this match or not? Which sounds like a good approach if you want the higher accuracy. So I thought that was an interesting one. And I'm also thinking about like, is there a way to automate that where a user can be identifying it? How many do they have to identify? And then create the model on demand, then apply it in parallel.
Yeah, thanks. I mean, it's a really interesting approach when you're searching for very similar to this and this and this and this, and you're just grabbing a bunch of examples and then you fine tune to that. Thanks.
Isa?
Yeah, one question to you, Jason, for that. Do you know what this is being trained on then? Like what the ground truth for similar pictures is, or similar embeddings?
I think, I don't know this because I'm not part of Earth Genome, but they've done things for like identifying cattle feeding lots and things like that. And so I think they have a bunch of ground truth there that they use as input.
Okay. I mean, our typical approach would be an iterative one. So you start with one example or a couple of examples. You do cosine similarity to find a few more, and then you feed that into a model.
Okay. Thanks.
Okay. Sumia?
Yeah, we have done something similar with Clay, and I think the Clay app was built around the same concept. So you start with 1 or 2 examples and you do a vector search, and based on the results, you kind of do human in the loop. You label a few more examples, and within a minute you have like a very good classifier. And I've seen that work. That's a very easy way to get to a classifier model for anything that's of interest to you. So the problem with embeddings in general is they're very high dimensional and they represent a lot of things that make sense and some things that don't make sense, and it's just like a super easy way to get to a model which does classification really, really well.
Okay, thank you. Sam?
Yeah, just to say, a couple of months back, I put a repo up on LinkedIn about finding sawmills in the Pacific Northwest, doing this kind of iterative approach. Start with just finding a few examples, doing similarity search to build up like a data set big enough to then train a random forest on top. So yeah, that's I can post that link on Slack if that's useful as a reference.
Yeah, please, thank you.
Thanks, Sam. Now I remember where I've read it.
Okay, good. Then I think it was Isa. Shall we have a website? Is that coming from you, Isa? This question?
I didn't put it there, so I don't know who originally put it in the agenda.
Okay.
But Thomas and me also quickly discussed about this, about just having like a super simple landing page for the sign-on, just to make that simpler to share with people if they want to join our community calls and join the Slack channel. So I just wanted to ask whoever put it there if there was another idea behind this or other ideas what we would want to share via website.
Nobody, at least in here, it seems. Okay, maybe we can come up with a proposal what to do. I think we should try to use stuff which is already hosted and working, and nothing we need to host ideally. Okay, now we have 14 minutes left for our, let's say, focus topic, discussion and brainstorming, embedding storage standardization. So storage formats and probably also what we heard before, from Element 84 catalogs. Also, Jonas is in the call. He's working for the Embed to Scale project to find out how to catalog embeddings in the stack. So I think that would be an interesting angle for this discussion. So I won't moderate, just feel free to talk. And if it's ending up in chaos, we still can use the raise hand function, but let's try to have an open discussion.
The one thing I was going to note is Chris Holmes sent out like a survey last year with this link that I'm pasting in there with people to like a place for people to submit how are they representing vector embeddings in Parquet. And so far it has Earth Index and Clay there, but they've described how they're doing it. And I think this is a good approach where you identify like first for people who are generating vector embeddings in a format like Parquet, how do you do it? What are the column types and things like that, or the naming, the conventions, and then using those real world examples, you can start to develop a standard that will be following whatever they did, because obviously they have real world experience.
Jonas, you wanted to say something?
Yes, I started to make an extension for Stack to catalog embeddings, which link for that is in the protocol of last session. I didn't really follow up on that one yet because I wanted to wait what this community proposal that we submitted ended up being, so that I don't develop something here and in the end the community does something totally different. I just thought it might be nice to use Stack because it's something that is used in the Earth observation community already. And it might be nice, of course, if we can also use that to also query the embeddings, what was kind of in a way what the white paper proposed, because I think that would really put Stack on the next level if we could have something like content-based search in there and not only metadata-based search.
Maybe backed by a vector database for speed or something.
Probably, yes.
Okay. Yeah, I find also out that it's probably more important to have the catalog than the embedding format specification itself, because people anyway might just store embeddings in any format, and obviously it's a huge compute effort to recode all those. So maybe it's more important to have a proper index to tell people what's in this format and how to access it, and especially link it back to the source data and modalities and everything. I think that's a really important thing. Yeah, yesterday I spoke with Isa about this, and we said probably it makes sense to have some mandatory values like timestamp and geolocation from where the source comes from, and then probably let's say optional or auxiliary information, and that's probably something we can just agree on, some sort of a JSON schema where we define how this structure looks like. And people then are free to either put the free text into this auxiliary information, but if we have a specification and people anyway have the information, they could stick to that JSON schema and just put all the auxiliary information into that free field. I don't know, Jonas, how does this work in Stack? That's basically how it works. Now you have like predefined fields, and you have a possibility to have more unstructured, unregulated auxiliary information attached to a Stack item as well, no?
Yes, Stack itself only defines a very small set of core attributes per item, and then you can have custom extensions that specify further fields, so that you can make the item fit whatever you need it to fit, really.
Okay. Then it would probably make sense to try to use this community to agree on this specification for the Stack items. Because at the end, it doesn't matter if it's like GeoParquet or serialized vectors of torch or whatever. Okay, there's Alex raising his hand.
Thank you. Yeah, regarding the storage aspect, maybe it's an early point, but just to consider for the future. If we're going to be developing use cases or looking at different ways to create embeddings with the models, for example, through TerraTorch, do we want to consider as a community hosting like embedding databases so that we don't waste time like recreating these? For example, if they're created with a model over Sentinel-2 for X amount of years, if we want to create these data sets in host, also to have like intercomparability between our use cases, because I don't know if at the moment we're sort of like launching our ways to creating these embeddings and then have different databases, and maybe as a community we could centralize some of these embedding databases and have it like accessible to the public and between ourselves. Maybe just an early thought.
That's a good point, yeah. I mean, one thing is with Stack, you have the possibility to kind of federate. No, you can have your own Stack catalog and people just query multiple. That makes it a little more easy with coordination. Or if you have a central Stack catalog, then who has write access and so on, or who is overwriting stuff from others. And on the other hand, I think embeddings are smaller compared to the source data. If I got this right, no, please correct me if I'm wrong. And we might be able to host them on sources like Hugging Face and Zenodo and I don't know what. And that's a valid endpoint for a Stack item, I would say. No? So it makes sense, yeah. And if the format is like somehow, so if we specify how the format has to be specified in the Stack items, then the machine can automatically do the conversion. So we need to, then you can automatically use embeddings on two sources and somehow without a lot of manual work, you use those if you have the metadata about that is the problem. The metadata is not attached to the embedding usually. You could, for example, in GeoTIFF, but or X-ray, serialized SAR folders, you can, but it's like a diverse ecosystem. So if you have a central agreement on the metadata, I think. I feel that's the most important for now. I don't know how the rest of you feels about it. I mean, Element 84 came up with the idea. No, I don't know. Do you have any comments on that?
Yeah, none other than I think looking at, like I was looking at some of the examples in the GitHub repo, like Earth genomes, like what they're putting in there. And I think it's like a great place to start. They've identified a bunch of different fields, like the model and the provider's licensing, the model metadata, the data set metadata, like, and things you put on the embeddings themselves.
Okay. Did you share that link already, or could you share it?
Yeah, yep, that's at that GitHub repo that you pasted in.
Ah, that okay, that's already in the agenda then. Perfect. Good. Can we then maybe briefly talk about the storage format? Is there anything you tried and you know it works? Like GeoParquet, serialized torch tensors, SAR. Did you notice any advantages and disadvantages in those formats?
I think, Adil, did you have any particular? I think we did Torch, and I think we also may have done Parquet as well.
Yeah, we, for our various demos that we have, we just stored them in a GeoParquet file. And like before that, for a more simpler demos, we just stored them as torch arrays, and that was good enough as long as you have just like 100,000 or so embeddings. But yeah, if you want to scale it up, then formats like GeoParquet make more sense.
Jonas?
Yes, my question would have been exactly that. Why did you choose GeoParquet here? For me, it's like we have raster data as an input, and then we feed subsets of this raster into our model to generate the embeddings, which then should also be able to be represented as a raster. So why did you decide to use a vector data format then?
I think it kind of goes, I mean, it was partially because that's what it seemed like other people were using. And it also allowed for, like, you know, all of these other columns that you'd want, like the spatial footprint and the, you know, the time that it was taken at and other things like that. But really, like, we didn't do much with it in that format. It was basically used as, let's put it here, and then we'll load it into a database where we'll be able to actually like use it instead. I should also mention, linked, I think, at the top of this document, along with like a bunch of other topics, there's the idea of putting it into ZAR, which I think is an interesting idea. And I think that's like, that could be a future discussion. And I might try to get like Ryan Abernathy, who came up with that idea, to talk about it. And one of the ideas is to put the index, like the index itself in ZAR as well. And then, because one of the problem, like, let's say you're going to chip up all this input data and you want to create like a big catalog, you can go from 25 million scenes into 20 billion or 40 billion or 100 billion vector embeddings really quickly. And you can't put that much data, at least I don't think you can, into like Postgres, right? And expect you're going to get good results. So you need some way to do that. And how do you create a vector embedding index on that if you want to do, you know, this at scale? And so, you know, like, do you distribute cosine similarity just running individually? So putting it at the, like, actually creating like kind of a tree of indexes and putting the index serialized into ZAR, you could build a system where you load the indexes and dynamically use those for searching at runtime. There's some kind of like database scaling type challenges with this.
Thank you.
Okay. And on the other hand, you could argue it doesn't matter too much. No, it's responsibility of, let's say, the data provider, and OpenEO can like on the fly transform stuff anyway, probably. No, so that's also another angle of looking at it. So you have to decide how you can store it efficiently, how you can search for it efficiently. Boils down that the catalog is still more important probably than the embedding storage format. Okay, we have 1 minute left. Any other comments on this topic or any other topic? Everybody happy? Maybe last question is, when shall we meet again? Just today in 1 month? Is that fine for everybody? Same time slot? Mia?
I'm just curious, like this is something that I was discussing with one of my colleagues last week. Like, what are people using embeddings for apart from semantic search? Like, do we see any other examples apart from semantic search with embeddings?
Yeah, I mean, we have this 4 use cases from the Embed to Scale project, and I hear that in other occasions as well. So it's embed to find, that's the semantic search. Then there's embed to transfer, obviously, because embeddings use up less space. I would even say embed to store, kind of, no? And then there's embed to train, where you just train on top of the embedding and you skip the execution of the backbone. Obviously, you cannot unfreeze the backbone then for fine tuning. That's probably a disadvantage. And then there is embed to infer, where you just use it for inference on top of the embedding with the decoders and heads. You either pre-trained on the embedding, or you could also use a decoder and a head, fine-tuned on unfrozen backend, and then use this on the embedding, which boils down to use a frozen backbone, basically. So there are 4 main use cases. Any other use cases probably someone has? Otherwise, okay. Good, let me just double check on the next date. So if you say it's today in 1 month, that would be August 15th. Is that correct? Just 1, 2, 3. No, August 8th. So it's August. It's anyway scheduled. So okay. So if no one, if there's no critical mass telling me it's a bad slot, let's meet on 8th of August, same time slot. Okay. Good. Yeah. Then thanks everybody, and looking forward to meet you in 1 month, and probably have some more updates on some interesting subtopics. Take care, and let me know if you need something. You know where to find me. Yeah. Take care. Bye.
Bye. Thank you. Bye.
Thanks. Bye.
Thank you. Goodbye.